Good morning, students. Now going to today topic is transpiration. Transpiration. So, according to syllabus, we are in third unit. So, in this third unit, actually, the third and fourth two units is also physiology topics. Then the plants water relation is the third unit. Again the fourth unit is photosynthesis. So here already we studied about the diffusion, imbibition, osmosis, at the same time osmotic pressure also. Then the potential and absorption and transport of water. So here, then transport of water, that means xylem and phloem at the same time. And the transport of water, it is ascent of sap. So this is one of the important question. At the same time, stomatal structure, that means transpiration is also important one. So ascent types of just already we study about in intermediate level. Then it is the theoretical level. So I will skip this one. I will explain tomorrow. This is the complete theoretical topic. At the same time, we have to the most of time it has. So in the same simple topic, at the same time important topic in examination point of view, ascent type stuff as well as stomatal, both are also important. But today I will deal only stomatal structure and stomatal movement. Tomorrow we can study about that ascent type soap, because it has explanation very clearly. At the same time it has two variations of the theories also. So today I have a list of time, that's why I am not taking that topic. Just this one is the already you study about this topic, at the same time simple topic. That is the only reason. When now going to the topic transpiration. Then that is the transpiration is one of the that means water evaporations. That is its movement one kind of way to another kind of way. That is the transpiration. So here, when the transpiration is the process of different types of the water movement. That is the water ions. That means it's chlorides or magnesium or potassium, hydrogen water molecules, different types of the waters. Then waters is completely then going to the transpirations. That is the which water is very important or which water is evaporate at the part of the plants in different type of the vapors. The water vapor and then different type of the water vapors. That is the evaporations is also different type of the evaporations. When, for example, we have some kind of water boil in a bowl, that vapors is first of all it is very simple and small, just like a foam like vapor. Then again the most of the water is boiled, that is complete high vapor. Whenever we can put in the pressure, so then how much of the pressure we can then the pressure then opposite direction, how much of pressure, then the water is also that kind of evaporations. Then the plants is also, most of the plants evaporate the water, that is the guttation. Sometimes in the plants most of the water in guttation we can observe in early morning the grass again small drop of water, or around of the bottom of the leaf also we can find out the water vapors, different type of the water vapors. That's why then the transfer of the process, that is that it's completely that most of the water transpiration in aerial ponds only, not in internal ponds. Aerial ponds most of the water is transpirations. So here then water vapors transpiration is automatically it has in the different type of the transpirations. that is the most of it has in the stomatal transpirations or cuticle transpiration or lenticular transformations. So, in the water transformation, it has in the then stomatal transpiration, cuticle, then lenticular. So these are the different general three types of the water transpiration: lenticular or cuticular, lenticular or cuticular. So lenticular as well as cuticular type of the water transpiration. Then the stomatal transformation or cuticular transformation or lenticular transformation. So these three variations of the transformations, then the levels, it most of the actually the transformation it has in the first of all the stomata, that is the stomatal transformation. Then the stomatal transformation, it's most of the stomatal we can observe in leaves. Okay, most of the stomatal we can observe in leaves. The type of the leaves is completely the stomata transpiration that complete it occurs through the stomata. Then that means the transpiration that occurs through the stomata. The water vapors or loss of water or transpiration, it's followed the stomata. That is the stromatal transpirations. Okay, so it's through the stromatal waters. It's through the stromatal. Then the cuticular type of the stomatos. It has we have the many internal structure of the layer tissues, meristematic tissues or apical tissues, cuticle layer, epidermis layer, endodermis layer. These are the different types of the layers in anatomical structure. That is the internal structure of the leaf or a plant body, complete plant body. So then here it has most of the plant body depend on the cuticle layer, at the same time epidermis layer. Then the layer above the, for example, most of the plants or that means anatomical structure, that is the stem or a root or a leaf, they have the most of that is the ones surrounding of the envelope. For example, cell surrounding the envelope, plants is also surrounding plant cell wall. So these are the different comparison. Then the epidermis layer. So here first of all, for example, then the epidermis layer. This is the anatomical structure, that is the epidermal layer. For example, so this layer is the cuticle layer. Okay, this one is the cuticle layer. So here, then that means here above the epidermis layer is called the cuticle layer. Okay, right now this is the cuticular layer. This is most of the sensitive layer. At the same time, minimum layer of the cells. the minimum layer of the cells, that is the cuticle layer, epidermis layer, above the epidermis layer, and minimum transpirations, it's called cuticle transpiration because it is a very thin layer at the same time envelope or it is supporting or help to the epidermis layer. In most of the plants, then that means stomatoes. The stomato structures it will be we can observe or we can see in the endodermis layer as well as epidermis layer or cuticle layer. So cuticle layer at the same time endodermis layer. We can find out the different type of stomatal structures. So here also this one is the stomato structures in cuticular layers. Okay, then lenticular layers. That means these are the secondary layers. It has a growth of whenever the growth of the primary layer as well as secondary layer or primary cortex, secondary cortex, and these are the different types of the layers in anatomical structures. So here also the secondary layer, that is it forms completely the lenticular cells, then meristematic cells at the same time, submeristematic cells or lenticular cells, parenchyma cells, sclerenchyma cells. These are the different types of the cell, layer by layer arrangement of the cells layers. Okay, then this one is the arrangement of the second layer. It is involved in the position of the second position at the same time it has in the second layer. Then this one is complete in the lenticles, the growth of the second lenticles. Then the water evaporation through the lenticle cells, that is called to the lenticular transpiration. Okay, then almost all these are the different ways of the water transpirations. Okay, now stomatals or cuticular or lenticular layers of the transpiration. So what is the movement of the transpiration at the same time? Then what is the structure of the stomato structures? That means we have already we discussed about then the second then that means third sem anatomical structures, that means apical meristematic tissues, parenchymatous tissues, different type of studies. Then this is one of the topic in that type of the third semester also. So now once again we can read. Then first of all, then the beans-like structure of arrangement, that is the stomatos. Okay, right now. So then the leaves complete different or number of stomatos. Then here the large number of then the find out of the stomatos is ventral layer or lateral side, dorsal side at the same time ventral side. So both the sides is also quite opposite number of stomato structures. That means in for example upper layer, down layer, back, front and back. Then the leaf is very dark in color front, then light in color back side. So when the stomatos is number of stomatos almost are arranged is also in this front and back is also different variation number of stomatos. The epidermal surface of the pore, that is the stroma. Then first of all, the stroma, it means epidermal surface of the pore, that is called the stroma. Okay, that means here, now this one is the pore. Then it has most of the stroma surrounding. What is the surrounding? It has the two types of the gourd cells. These are the gourd cells. These two also, then gourd cells. So it has arrangement of the two gourd cells in between the gap, that is also pore. The pore is called stomato. Okay, right now. Then the pore is always, it has in the two types, one pair or two gourd cells. Then the surrounding of the gourd cells, it has in the different type of the gourd cells is also. Then the surrounding of the gourd cells, it has most of the subsidiary cells. This one is the pore. It has the surrounding of the gourd cells, it has subsidiary cells. These are the generally subsidiary like cells. So in these subsidiary cells, now this one is the pore, this is the gourd cells, these are the subsidiary cells. Okay, then here this structure is also different type of the stomatose structures will be, we can find out different types of in the plants. That most of this performly it is all the, that means what is that gourd cells is looking like a just veins like structures or kidney like structures, that is. So here these different type of the stomatose that has, the stomatose is also depend on their morphological structures. It has in the two variations of the stomatose, that is the monocotic plant stomatose as well as dicotic type of the plant stomatose. That structures, the monocot plants is different in structures as well as dicot plants is also different in the structures. So and depend on the morphological or taxonomical structures, the stomatose also then the different type of the structure. So here then this one is all the modified, then the dicot, the gourd cells are different in at the same time monocot of the gourd cells. Then cells is also different at the same time. Then the monocot cells, dicot cells is also different type of the variations. That variations, that means here the dicotic type of the cells. Now simple identification only, that is the dicot cells is always that structures completely or that means veins or kidney like structures. Okay, monocot stomatose, at the same time dicotic stomatose. Then here the dicot stomatose structures we can find out easily, that is the veins or kidney like structures. Then the monocot stomato, that is in dumbbell like structures. Dumbbell like structures. For example, this one. These are the monocotyl type of the stomatoes. These are the dicotyl type of the stomato. This is looking like a just beans-like or kidney-like structure. That is the dumbbell-like structures, dumbbells. Then dumbbell-like structures of the stomato. These are different type of stomatoes, different ways, at the same time different size, different structures also. That is the open stomato as well as the closed stomato. Then the pore, whenever the pore is closed in some time, that is the closed stomatos. Pore is open, that is the open stomatos. Almost all in daytime, most of the, that means open stomatos. Then here the different type or different structures of the cells. Then the pore cells. Pore cells, it is in the God cells. Then surrounding of the God cells, that all is the subsidiary cells. Then the subsidiary cells, that completely it has in the, that means different type arrangement of the cells. Then here the God cells, it has most of the chloroplast. Okay, the God cells, that means here the God cells, it has most of the chloroplast. These are the chloroplast. That different type of that it has in the God cells and then chloroplast. What is the further duty of the subsidiary cells? These are the transferred to the subsidiary cells. So finally about that, these subsidiary cells is also must have the chloroplast. Then these are also chloroplast. Okay, right now. Then the God cells and subsidiary cells. Most of these two cells having a chloroplast. Then here, then most of the subsidiary cells as well as cells, it has in the formation of the different type of the normal type of the formation, at the same time complex type of the formation. Then here the normal type of the formations of the subsidiary cells then go to the difficult of the dumbbell shape of the monocotyl type of the cells. Then anyhow the both of cells is also going to the different or difficult type of the cells. Then it has the stomatos is most of that is the subsidiary cells, the God cell stomatos. These all in the different. Then these tomatoes is also different type of the plants in different type of stomata. That is that means, for example, most of in the xerophytic plants, they don't have stomatos. That is the plants is called succulent plants. The absence of stomatos is called succulent plants. Then the presence of stomato, that means it's different of than the stomatos. That is the stomatal plants, hydrophytic plants. Then xerophytic plants and hydrophytic plants, or normal terrestrial plants. So here, then difficult of these type of the plants is it almost of generally the stomatos are open in day and closed in night time. Why? Because the closed in night time. That maybe it has the stomatos is open in daytime. That means the stomatos is constructed to the God cells as well as subsidiary cells. So both the cells they have to the chlorophyll. Whenever the chlorophyll, then it presents in the sunlight, it's make their own food material, photosynthesis. It has in the utilize the sunlight and water chloroplast or chlorophyll. Is these among these it consists of the photosynthesis. That is the reason that most of the stomatos are open in daytime, closed in night time. They cannot photosynthesis in night time. Only respiration or only night time. The respiration, they don't have any stomatoes. They don't use of the stomatoes. So only night time that is completely closed to the stomatoes. Daytime only the stomatoes will be open because of the utilize the sunlight. At the same time, synthesis of the autotrophic plants is autotrophic plants. Then the type of plants, they get their own food material. That is the reason. So the stomatoes will be opened in daytime, closed in night time. That is the one of the in the mention of the stomatal structure. So here the mechanism completely. That means the water transferred to one cell to another cell, or stomatos or chlorophyll is transferred to one cell to another cell. How can it possible? Then now going to topic, that is the God cells, that going to the subsidiary cells. So here then the presence of the light completely stomatos, then open and stomatos closed in the absence of light. That the movement of stomatos that completely increase or decrease in the number of the stomatos. At the same time, it is depend on the potential. Then many theories of the potential. That here then the starch sugar hypothesis, then photosynthesis, God cells, the Stewart theory, potassium transport theory, Sayre theory. These are the 5 difficult of the theories. Then the first of all, the photosynthesis mechanism of stomatal movement. Mechanism of stomatal movement. It has in the 5 different types of the theory. Now, starch sugar hypothesis. Number 1. Now, number 2 is potassium ion transport. And the third one is God cells. Photosynthesis in God cells. Photosynthesis in God cell, Stewart theory and Sayre theory. Stewart theory and the 5th one, last one, Sayre theory. So these are the mechanism of transport of the variations of the stomatos theories. So this one is the structure of stomato. Then this structure of stomato, these are the different types of the pods. These pods will go into movement of the one pod to another pod. That is the pore cells to the God cells, then God cells to subsidiary cells. What is the movement at the same time? What is the ions or formation or ions movement in these different surrounding of the cell, ion movements of the cells. The type of the ions is also difficult. Then the potassium ions, magnesium ions, chloride ions at the same time, there are different types of the ions. Then the ways of the ions, what is the experiment at the same time, what is the transformations of the ions. So this is only in the structure of stomatoes. Next, I will go to the mechanism of transport ions in next class. So, thank you students.